Hello and welcome back once again. So, yesterday we were able to integrate Dagster as part of our ETL pipeline. So, Dagster was tasked with the responsibility of running the entire ETL process. So, and that was about getting data from our S3 bucket, then doing the transformation, feature transformation. Then after that, we were able to now save that data in our uh, BigQuery as our offline store. And so that was what we covered yesterday. So today we will be now handling Feast as a feature store. So Feast, remember Feast, this is our feature store, and so it's not really a database, but it sits on top of our offline data store, that is a BigQuery, and also Redis, which we will develop it later on. So Feast sits on top of this, and its main responsibility will be fetching the features that we will be requiring when it comes to doing the predictions and even training the model. So Feast will act as gatekeeper when it comes to that. So that means we are going to define what features we need. Then Feast will actually do the job of doing the merging and all that. It will retrieve all those features from the different tables, then organize those into the spine that we actually created. So the spine is like an entry into the many features that we have. So with the spine, then Feast will try to populate that entity table with the necessary features that we have requested for Feast to find. Okay. So once that is done, then we're able to generate a table, and that table is the one that we are either going to use it to build our model, and or if it's or when it comes to the predictions, we are going to use that to now generate the predictions. Also remember that when it comes to the predictions, we are also we are doing this in multiple ways. So the first one is an offline prediction. So offline predictions using a BigQuery, and we can also build this model to also include real-time predictions, and that we will be using Redis. That we will be setting that a little bit later. So for now, we are focusing more on the offline predictions. So also yesterday there was a slight problem when we are running Dagster. We weren't able to complete building the entity table. So for today, I'll just run this afresh. Then while it's running in the background, I think I was able to solve that challenge. I think right now it's running okay. I just commit the code to Git so that you can also have a look at it. But in the meantime, I'll just run it on the background. And as it is running, we're going to start on Feast. Okay. So what is Feast as a feature store? Again, we can just use a simple search. When you're talking about Feast, so Feast as a feature store, Feast as a feature store. So what when you're talking about Feast, yes, Feast as a feature store, then when you're talking about Feast as a feature store, what is this feature store and why do we need this feature store? So in machine learning, when you are building machine learning models, definitely we are working with different sets of features or different types of features, and each feature usually carries a meaning or some type of information. Again, features can be of different tables. So why do we really need Feast when it comes to building these models? So there's this paper or a blog post I got from Google, and it tries to explain essentially why we tend to use Feast. So Feast provides a powerful single data access layer that abstracts the ML features storage from feature retrieval, ensuring that ML teams models remain portable throughout the model development and deployment process. So you might have you might be working when you're working as ML teams. In most cases, you won't be developing a single model. There might be multiple models that you will be required to develop. So in our case, for example, the first model that we are developing is a spoilage risk model. And this is a combination of a classification model plus a regression model, where we are leveraging regression to try and explain to us what is the rate of wastage. Classification model is a probability based model that tells us what is the probability that this type of shipment is actually contaminated or is having a problem. Okay, so once we get the probability, then we can assess the rate of spoilage based on that probability. So then the next model that we are supposed to come up with is a model that can be used to determine demand in a particular store. So that's also another model, a second model. Then we have another model, and that is about the markdown. Markdown meaning that we have the probability of spoilage of this particular shipment. Then based on that, we're able to predict the rate of spoilage. What is the waste rate? Then if you have that information plus demand based on these products within our store, then we're able to actually use this information to determine discount or markdown we can assign to these products. So if it's a product that, for example, has a lower shelf life, and also it is showing signs that if we continue harboring these products on our shelves, then we might incur losses. So we might estimate the demand. Then based on the demand, we can actually try to offer discounts on those products, and by so making sure that we are able to clear this production on our shelves. So it does not mean that that the shipment has to be in a bad condition. Maybe we did order this shipment, and then suddenly we are having a problem with the traffic. So what is the best way, instead of this product getting spoiled on our shelves, what's the best way for us to actually clear this and maybe look for another type of product that is showing signs that showing better signs? Okay, so as you can see, we have multiple models, and I don't think that a single person will be handling all those models at a go. That means that different teams will be tasked at handling those different models. And what is the best way to actually ensure that all these teams are using features from a single source? That means we have a single source of truth, and all these teams are actually leveraging or are using the same features from a single source. And that's where Feast actually comes in. So it will enable all these teams to have a single source where we can build the features we want. Then Feast will enable us to retrieve those features, and we can build these models simultaneously instead of building a single model, build, deploy, monitor. Then after some time, we start developing the other model. And so that's where Feast enables us to actually build such a multi-model ML systems. Okay, so compare these to organizations who opt to build their own homegrown feature store. These projects often achieve a quick success with focused effort by small teams. So this is some of the documentation that you can get from here. So Feast addresses these common organization level ML scaling challenges head on, enabling customers to achieve far greater leverage from their ML investment by standardizing data workflows, development process, and tooling across different teams by integrating differently with the tools and infrastructure that these teams already use for key steps like feature transformation, data storage, monitoring, and modeling. So this is what I've actually talked about, because we have different teams and are building different types of models, and how best can we, and in such a case or in a scenario where these models have to communicate within themselves. For example, in our case, the Markdown model depends on depends on the output from the model that predicts traffic, okay, demand, and it also depends on the output from the spoilage risk model. So if we are working on such a model, then we need to have a single source of truth. Otherwise, we're going to be the train. I think it's the train serving skewness. So to avoid that, then you need a single repository to handle that process. Accelerating time to market, because different teams can handle different ML models, because we are picking from the same source. Productionalizing features. Again, this is also another, I've also talked about this, and also eliminating expensive data inconsistencies. So in our case, we are having 3 models. That means in an ideal scenario, assuming that FEAST is not part of the plan, each of these models will require us to build their separate ETL processes, and that is a technical debt that you don't need to incur, because you'll have 3, 4, 5, 6 ETL processes or ETL pipelines that you will be required to build, monitor, and again, that is also cumbersome. It's a tedious process. But in this case, depending on the models that you are going to have, you have a single ETL process, and it handles and it sits at the basis, or forms the basis for building n types of models that you will require. So this is an example feature, or example flow of how the feature store actually operates. So we have the ingest streaming data, or a batch data. So we stream that data in. Then with the feature store, we are doing the transformation, storage. Then we have this registry, and this registry is where the data scientists will be querying. They will define the features that they want. They'll present those features to the registry. The registry will now, using the entity table, we're going to use that to pull the features that we need. So you might be having 200 features, and in a particular model, you don't need to use all those features. So you can only define a specific, let's say 40 or 50 features, then pull those features from the registry and train a model based on that. Then with the features, then you can also do the model serving, because again, we're going to use the same features. FEAST will also enable us to perform that, and that's what we can use Redis, because in most cases, we'll use that for live predictions. Okay, so that's how we can actually integrate FEAST for that. So the role of feature serving in ML Feature Store. So it's quite a nice blog post that you can actually go through and try to understand why we need FEAST, especially if you're building a multi-model system or architecture. Okay, so that is briefly what we are going to be tackling today, and this is a blog post. So let's now transfer the ideas of the blog post to now actual building the system. So let's see how we can build this system itself. So again, I'm not going to write this code line by line, because that is going to take quite some time. What I will be doing is I will be trying my best to show you what I've already done. Then we can just try to explain what is happening. So for this one, let me just materialize all. Then let this run in the background. Okay, so talking about FEAST. So the first thing that we need to do, I'll create this feature store. Then in your root folder, I'll create this. You have to create, but I'll just paste this. So this is the feature store, and this is what you're going to be using. So under the feature store, with FEAST, you have to create the entities. So the entities define. So here you're defining the entity. So the entity. Remember, here we are trying to explain to FEAST, like these are my primary keys and the tables that I'm having. So based on these primary keys that we are having, okay, I'm just trying to explain this in a layman's language. So based on these, entities or the table or the primary keys that I'm having, can you use this to traverse my features and try to populate the entity table. So if you want the so you can still just do a quick search. So entity feast. Not bad to okay. So when you're talking about the entity table, so the entity serves two critical functions within Feast: feature mapping. So they map a collection of semantically related features to a specific real-world concept. So as you can see, we are having like the primary key, for example. So those are the joining keys that a Feast tends to utilize. Each table will have a joining key, and that key, similar to a SQL, when you're doing the SQL joins, they will also be required to use those keys to merge the different tables and so on. So you will require that. So we define that using the entities, and then once we define that, this will use those to traverse your different tables and extract the tables that you actually need. So in our case, we did split this into 4 tables. No, 3 tables. Is it 3 or 4? I think it's 4. We did split this into 4 tables. Let me see. So we have the products, dimension, sales, and into 4 tables. And each table must have a primary key or an entity key. So that Feast will use that entity key as a matching, because again, you have to do the left merge and so on. So Feast will do that automatically. You won't be doing that manually. Feast will be doing that on the back end. So it will need those keys to handle that entire process. Okay, so that's how entity keys will be important for us. Okay, now once you have your entity, then you'll also need to define your features. So how do we create the features themselves? So with the features, we are trying to master the feature views. So because Feast, we have to find a way to identify the features that we have, so that Feast can actually isolate them and when doing the merging itself. So essentially, with the features, we're just giving a list of the features that we have. So you provide a list of all those features that we have, so that it's like an identity. If I'm telling Feast to look for these features within my in my offline store, then at least we should be able to tell Feast that only look for these features that I've specified. Okay? So that's the work of it. Without explicitly stating the features that you need, definitely it's going to pull all the features. And again, features. I need a selected features for that. So this is like a repository of all features that you have. So you can give a list of all the features that you have. So this is like a repository, and also telling Feast that these features are found under this table, and we have provided the entity for specific table. I think entity record ID. So record ID store. So this transaction entity. This is for the store. This is for the product. So we have provided the entity, the primary keys. Then you have provided the features. So as you can see, it's just a similar way writing the queries in SQL, because you have to, if you're not merging the entire table, you'll give a list of features that you need, and also you need the primary key. So that's the joining key, and that we'll be getting that from the entities. Okay. So yeah, so this is what we, maybe just as a small detour, this is what yesterday we were supposed to be getting. So you can see we have materialized all the tables, materialized everything. So that means that we have populated our offline store BigQuery. So again, later on I will show you that. Okay. So okay, so this is the features. Then once you have that, you can create the now the YAML files. So the YAML files. So okay, I have for the local storage, because again, remember when I was building this, I was able to set explicitly that I'm building this such that I'm able to work within my local state, my local workstation, and even if we deploy this in a production, we can still run those commands. Okay, so let's start with the local feature store product. So this will be in production. So in production, I will be relying on this especially for online prediction. So this one is like this is a YAML file where we define where is our registry, where is our offline, and where is our online. So for offline predictions, this is where we will be. Yeah, so this is our offline storage, and this is our online storage. So for the offline, remember this, we need to change this into, we need to go to our config. We are using data repository. Yeah, this we need to, for our feature store, we need to change these two. Then we also need the correct retail omnichannel features. That's the same. Yeah, this remains the same. So this is our offline store, and this is our online store. So for the online store, this is the feature. This is for the hybrid. Hybrid meaning local and on the server. Then, but let me, for production, I want to specify. So for production, then I need to change this. We need to specify where we are. This when you deploy this to the server, this is what you are going to be using. This is the specific the YAML file, and then let me see. What is the YAML file used for? In I think where we define the feature store YAML. Yeah. So even if you go to the documentation, so you're able to see. So we define the project name, the registry, specify the path or storage. Yeah, this is what I wanted. The registry is the path of the storage location. So are you using offline or online for predictions? Then this is the provider, the offline store, the online store. So no, for the registry, local file, I think for the registry, what I'm using, this is yeah, the S3 registry, S3. Then this is the so for okay, in my server, I think I've installed MinIO as my volume. I think so. It's the volume. So we need to link that. So this is where we will need to link that. So we take the endpoint and place it here, and then this will be the path to that. So generally, for let me try with the local. With the local, we'll have some sort of a SQL database, whatever that we might be using in our local store. You can see in the documentation, you can also see that. So we're using a SQLite like a database for that. So locally, you can create this where you will be storing that. But for production, we'll be creating a volume and so on. Again, when that time comes, we'll also work on that. And so these are this is the said YAML file, and with the YAML, this is the core configuration file used to define the overall infrastructure, architecture, and so on. So the YAML file defines the architecture, the infrastructure that you need for the storage and where all features will be housed. So then the entities, those are the primary keys. Then for the features, so those are the features that those are the features. So these are the feature names and so on within that we are using. So the feature registry, infrastructure, and all that. Then the entities, these are the primary keys that we'll be using as the joining keys when populating our entity table. Okay. So once you have this in mind, or once that is running, so I'll just stop this. Yes. So we have our features, entities, foliage. Okay. So once that is done, let's try to. Do I need to add? Let me see. I need to add anything on the features? I think everything under the feature store will be housed within the feature store. So I don't think there's something outside that. No, don't think there's something I'm missing. Then with the features, as I'm waiting for the terminals, so I just let me under activate. Then I think under my shared we have me under my shared. I think I'll create another. So features. What am I talking about? Features. So this is how we define the process that essentially we will be telling Feast, okay, now that you have my features, the entity and the infrastructure and whatever, and what have you, now can you find these features? So what I've done is that then I need to define the features under config. Also under config, then you also need just paste it here. Yeah. No, it's supposed to be. Should be should be will be here. I'll just delete this one. Don't need this, so let me delete. So this is the ETL. So these are the features. So how do we tell Feast the features to pull? So other features I've provided the spoilage prediction features, and I've listed all the features that I want Feast to actually pull for me. So remember, we are also pulling these features so that we can also do an EDA and so on. So Feast will list. So we have given a list of all the features that Feast will be required to pull. Then I have this under shared. So this one is the file or the instructions as to how Feast should be pulling that file. So just to have a look at it. So these are the imports. This we're generating the training data, so environment and path configuration. Then these are the project roots, target identification. So this is the YAML file where we are getting the list of the features that we want. Then these are the environment detection, blah, blah, blah. Yeah. So we are pulling this from where? From our GCP, from our offline store. So we need to, again, pass the correct. We need to pass the correct table that we are getting that data from. So this is the correct table. So data that. Otherwise, we will be pulling from the wrong So GCP project ID. I think these ones, you know, where we defined all this. Dataset ID, this is the dataset ID. Okay, so this one we are defining the where we are getting that data. So the environment variables. Is a config loader. So this pass config and expand view field mapping, whatever. So load the feature list. So we are loading those features that we need to pull from a feast. So we are loading those features. Then this is the spine loader. So we need to load that spine. So if you want to look at the spine, let me see. We can go to. So we can go to, I think in my artifacts ETL. So we have this storage spine. Then I'll open with data wrangler. So let's see how the spine looks like. So spine is just a small table, and that is the target variable plus the identity keys. Identity keys meaning the primary keys and what have you. So that is what will be contained under that table. So it's just a small table without a lot of without the other features. Then Feast will be tasked with the responsibility of now trying to populate that table. As we wait for that to load. So this one we are loading the spine table. Then dataset generator. Just declare this. This one you are done with. I don't need to. This one is done. Spine. Then I can just let's see now. I don't know why it's taking time, but let me. I can just close it and start it again. So let's look at open with the data wrangler. Okay, as we wait for that to complete, so let's now build the training data set. So build the training set. So these are the feature store, the BigQuery client, because remember where we are getting our data is from a BigQuery. So we are getting the BigQuery client. Do I need a model name? Where's the model name coming from? Feature list. So these are the feature list. So perform point bar. This is what I was missing the term itself. So the point in time join. So remember when we are doing our ETL, there was that time something we were also adding for the features. I think it's this one. Yeah, it's the event timestamp. So this one is very important because when Feast is merging all these files, it has to be time conscious. It has to be time conscious, and so that's the point in time merging or the joins that Feast enable us to do that. Otherwise, if you're doing this manually, you have to write those SQL queries, ensuring all those times and whatever are so yeah. So this is you can see loaded at 100,000 rows. So you can see this is the entity table. We have the record ID, product ID, store ID. Then we have the event timestamp, which is what the model uses when it comes to doing those point in time merging. Then this is the excess waste. So this is probability 0 or 1, as you can see. Then this is the regression model that we're also trying to build, target waste rate. So first we do the waste is excess waste probability. So that means once the shipment arrives, we do a prediction based on, let's say, things like temperature, types of storage package. Did the product arrive late? Okay, is it in the condition that we expect? So once we do that assessment, then the person doing the assessment will have to do a prediction. The prediction will generate a probability telling us in terms of, is it excess waste? Okay, so zero, closer to zero, that means product is in good condition. Closer to one, that means that that product has a high probability of spoilage. Okay, now once we get that probability, we, with the classification, it only gives us that probability, but we don't know the extent. What is the extent in terms of the waste, in terms of waste rate? So the waste rate, then we have to calculate using the regression model, and that we are able to get it from there. Again, waste rate is between 0 and 100%. So if it's a high probability, let's say if I get something that is higher probability of 40%, then we can again use that to calculate what is the waste rate in terms of that probability. So we can have the condition plus what is our estimation in terms of wastage rate. So you can see the entity table is just as small like this. Then FEAST will use this to now populate and add the other features that I think I've shown you. So this is the building the training data set. So you can see fetch the target spine. So we are loading the target spine. Once we load the target spine, so you can see the record ID, spine record ID, product ID, store ID, and the event timestamp. So enforce strict standards. Then trigger historical feature retrieval. FEAST automatically carries over the target label. So was spoiled as part of the entity. So we was spoiled as part of entity data frame. So initializing point in time join via FEAST. So retrieval data frame. So then we're using get historical features. So this is a method from FEAST. Then we provide the spine def. So these are the spine. Then we also provide the feature list, that we have feature list stating explicitly these are the features that we need you to look for us and populate the entity or the spine table. Okay, so the final training matrix is this. Then we will be saving that in a specific file, output path. This is the def endpoint main.py. So that's how we create that features. So remember, with the FEAST, we have to define what the YAML file was telling us. The YAML file was the core configuration, plus the overall infrastructure and all that. So once we define that, then we also need to list your features and in what table they are located, and also need to provide the entity. Once you define that, then you can define the features that will be required to pull from that, and you can define that. Then with that, I prepared the table itself, so that again, you don't need to alter the code, but you can just change this YAML file depending on features that you need. So for example, if there's another team working on let's say the markdown model, so they can just create a new YAML file and define the 3 or 4 features that they need when it comes to building that model. So again, so that's it. So I think there's nothing more to add on this. So hopefully when we run this, we are going to get that training data set. So let's run this. So with also, let me go back to my Dagstar assets. So here, I love to uncomment this. That at the moment when we run Dagstar, we can do the materialization in a single shot instead of doing it twice. So now we need to work inside the FEAST. So make sure that you're working inside the FEAST feature store. You need to work inside that folder. So I'll move to that folder. So I'll say cd feature store. There are, I think there are only two commands that you can need. Okay, that you need to master in most cases, and that is one fist apply and then a fist materialize. If apply and fist materialize, I think I let me see if I have that. That let me look at my no, not prepare that. Okay. So now once you are inside Fist, then I do think there are not many features that commands that I'm going to look into. There are just a few ones that we can use. So when you are setting it up, so quick start, activate, set it up, install Fist. I think this one has. Fist. Yeah, run a sample workflow. Then I think this is the one I want. So you first need to do the feature apply. So the apply command scans the Python files in the current directory for feature views, entity definition, registers and objects, and deploys infrastructure. In this example, it is the feature definitions. I think I've explained that, and sets up the SQLite online store tables. I know that we had specified SQLite as the default online store by configuring online store in feature YAML. So you can just do copy that, then that's the command that you're going to run under this. So first apply, then we're going to register all those features under, in our case, I'll go to the local one. So under local, we'll create a SQLite for that. So first apply. Then first time is going to take some time because it has to register all the features that it has to register all these features. It has to register all these features. That's why it's going to take some time. So first apply. So in my case, I did not use Fist pip install. Of course, you have to install the Fist, but I didn't create the initial to initialize the project and so on. Yeah, I didn't create that. Data. Mm-hmm. Generating the training data. Run offline. Okay, just the features. Then after that, you need to okay, this is the materialization. I think when you're running the Dagster, when you're running, this may take a moment. Yeah, when you're running the Dagster, I think that's where, in my case, I just combine so that when we run the features, we do the materialization in one go, so that we don't have that problem. People, where the error is coming from. Mm-hmm. It must be a mapping, not a string. Mm. Why I'm getting this type error fist report. Anyway, if I start working on this, I start working on this, might eat into my time. But let me try to run. Let me try to run Dagster with this. Let me see, so that we're able to materialize all that. Uh, or I can just use AI to debug this. Let me see if I can get something. So this is where sometimes okay, so that's the problem with that. Let me try to for features to I have the features to prod, local, and hybrid. Maybe it's confusing which is which, but activate fail panel. That could be a reason as to why. Okay, let me see if I can. Then I have this one for the local. Then this one is for product. Then testo.yaml is 3. And I think this one is empty. Yes. So, relative path here. Yes. So when activated, so tags or and try to just try to the projects that is fail omnichannel history, news, data, key, have provider, and be local. So news news type, online store. So you can use type, right? In the path, where do I want online dot no online store, then serialization, I have to practice the waiting game. Huh? Mhm. Or this should be the this should be was using Simlink. Just stop this. Cancel this. Then just this should be what I'm supposed to use under the feast. You need to remember working with Windows. Arrows tends to points. store channel, artifacts, artifacts. Then we create a folder here called Feast. Uh, yes, then Feast apply. Feast apply. And then yeah. So for Feast materialization, this asset awaits until all features and targets are written to the offline store. Then applies the Redis online store. So triggers Feast materialization to sync all updated gold features to Redis. Runs automatically only after all gold features. Okay, dynamic path, blah blah blah. So for online store, we need to materialize, and as you can see in the materialization, we materialize the last 30 days of data at the current moment. So with the online store, it does not store, it only stores the most up to date data, but not the, it won't look past uh, uh, like in the offline store. So it use only the most up to date data, and you can define that under this section. Or um, you can change that depending. So you can put 300 days, 30 days, 20 days, depending on how best you see it. Not not limited to, so you can change that depending on the use case that is. So okay, again, I do believe that this is going to wait for that. What I'll just do, I'll commit this code so that you can find it. Then you can run this on your end. If there's any challenge, then try to reach me. I'll try my best to help you whenever there's a problem. Having problems registering, he has this and here. So here, what I think, Now the problem is us using different us using different. Let me only retain this. Let me delete this for the moment. Let me delete local for the moment, and also let me delete hybrid for the moment. Then only run with this local. I think that is what that git add. Just fist. Mm, files are we committing? Files that I don't need to. The way you can avoid files from is the correct way. No, that's the way to avoid those files. Have to do it. Status. Again, I love to find out why I'm getting this error. Then I think here we're going to start tomorrow. In the meantime, I have the code. Try to work out on your end, see if it's working. No, as it's commit. Set. Okay, in some other cases, I was using a symlink. Using a symlink, but okay. Anyway, you can just remove the other YAML file so that we're not causing some sort of confusion which YAML file should be used. Then from there, it can just locate the single YAML feature. Back to that. We'll be doing the initialization. I don't know if I have anything to add from this. This should be the should be being. Don't know if tomorrow we are going to might be discussing about some other thing. So I want to be talking about that tomorrow. Then we can from here we can extract the tables, no, not the tables, the features. Then we can start on EDA and building the model. Let's give this time, see if it's going to respond. Okay, so also, if you're new to the channel, please consider subscribing to the channel. This is where you'll be getting these tutorials, especially when you're building learning models. My approach is to build production-ready models instead of anyway, I'll look into this, then try to work out the problem. Then once everything is okay, I will inform you. Okay. Seems to be more and more complicated. Okay, I'll work on this. Then in the coming session, I will try to explain what was the problem. Then we can sort it, then proceed. Okay. But try to, again, work with this, see if it works on your end. Then if you have any concerns, you can just get to the comment section and I'll try my best to get back at you. So if you're new, again, please consider to subscribing to the channel. It is support like that enables me to continue building such models. And my intention was to build models that we can deploy. We build production ready models that we can deploy, okay, into production. So my intention actually was building this model and deploy it via Kubernetes, because that is also another field that I'm trying to venture into. So at the moment, I can build models, deploy the models, but how do we move those models to live production with the integration with the infrastructure, Kubernetes? How do we monitor these models in production? Things like concept drift, data drift, integrating things like Prometheus, Grafana, and all that. So that was my main intention, and so that's why I strive my best to build production quality models. So if you are new to this channel, please consider subscribing. Just, I appreciate such help. Share it with friends and colleagues, and so until next time. See you. Have a nice time.